We're now moving on to vertical asymptotes using limits. And for these problems, I need to start off by finding the equations of the vertical asymptotes. And then after that, I also need to describe the behavior of the function to the left and the right of each vertical asymptote. All right, so a little bit of work to do for these kind of problems. If you want to find the vertical asymptote, step number one is I would recommend looking at the denominator there. So in this case, I have a denominator of x plus 2. And we take that denominator and we just set that equal to 0. And if I set that equal to 0, x would equal to negative 2. So there is my vertical asymptote for this first problem there. And then I need to describe the behavior of this function to the left and the right of each vertical asymptote. Okay, so in order to do that, what I normally like to do is I draw a number line here and I put that value where we have the vertical asymptote on that number line. And I want to look at the left-hand side, and I also want to look at the right-hand side of that vertical asymptote to see how it behaves. Okay, so we've done these kind of techniques before, and all we have to do is pick a number on the left-hand side and the right-hand side of negative 2. So on the left-hand side, we can pick maybe negative 2.01, and on the right-hand side, we can pick maybe negative 1.9. Okay, so what we're going to do now is we're going to take a look at the original problem here. So I have y equals to x squared all over x plus 2. And if I take a look at the left-hand side, I'm going to take the value of negative 2.01 and we're going to do a direct substitution step here. Okay, so if I do that, I get negative 2.01 all squared. And then on the denominator, I get negative 2.01 plus 2. Okay, so if I look at the signs here, I guess the numerator will always be positive, and the denominator in this case will be negative. So it looks like I have a negative, I approach negative infinity from the left-hand side. And then what I'm going to do next is I will just write a limit statement here. So the limit, as x approaches negative 2 from the left-hand side of my function, right? So we have established that it's going to be at negative infinity. Great. Let me erase this now. Okay, and now let's take a look at the limit on the right-hand side here. So now we'll take negative 1.9 and we'll plug that into our original function. So if I do that, I get negative 1.9. I square that, and then on the denominator, I get negative 1.9 plus 2. Now the numerator is always going to be positive, and the denominator in this case will also be positive. So negative 1.9 plus 2 is positive. So on the right-hand side, I have positive infinity. So if I write a limit statement here, the limit as x approaches negative 2 from the right-hand side of the function, I'll use f of x for short, that's going to be positive infinity. Okay, so that's the behavior of my function on the left-hand and the right-hand side of that vertical asymptote. And what we're going to do now is I have a graph here that we can kind of look at to verify our results here. So here's my graph right here, and as you can see from this graph here, if I can shrink this, we have a vertical asymptote at negative 2 here. And if I take a look at the right-hand side over here, and if I follow the graph, it looks like the graph, if I go to the right-hand side here, I go to positive infinity, right? And if I approach the graph from the left-hand side, I'm going straight down to negative infinity. So that right there is just a little diagram, a sketch of the graph that kind of shows you what these results mean when we graph them, right? Okay, so that's it for that first question. Now let's move on to the next question. All right, let's take a look at the next question here. So in the next question, I have y equals to x squared divided by 1 minus x squared. So for step number 1, let's find the vertical asymptote by taking the denominator, which is 1 minus x squared in this case, and we'll make that equal to 0. And then we go ahead and we solve for x, and if I square root both sides, I get plus or minus 1. All right, so I have two asymptotes. So what I'll do first is when I look at plus or minus 1, let's deal with the plus 1 first. So I'll put a 1 over here, and then I have another line here where I'll look at negative 1 separately. So my first step is let's take a look at the first vertical asymptote, which is 1, and let's deal with that first. So we have a left-hand side and we have a right-hand side for the first vertical asymptote. And let's go ahead and pick a number on the left-hand side, maybe 0.9, and a number on the right-hand side, maybe 1.1. Okay, so now we're going to take these numbers here. And what we're going to do is we're going to plug them back into the original function, right? So let's start off with the left-hand side, which is 0.9. So if I plug that back into the original function, I get 0.9 all squared divided by 1 minus bracket 0.9 all squared. And we're not, we don't care about what the actual numerical values are. We only care if the signs are positive or negative. Clearly the numerator will be positive. And this part right here, if you have 0.9 and you square it, that number is going to be less than 1. So if you have 1 and if you subtract a number that's less than 1, that's still going to give you a positive value there. Okay, so positive over positive is going to be positive infinity there. Okay, so how do I write a limit statement for that? I can write down the limit as x approaches 1 in this case, and we're approaching 1 from the left-hand side of this function f of x, and that's going to positive infinity. So that's step number 1 for this particular question here. And what I'll do next is I'll erase this, and I'll erase that. Now let's move on to the right-hand side, and this time we'll use the number 1.1. So let's plug that back into the original problem here. So now I have 1.1 all squared divided by 1 minus bracket 1.1 all squared. All right, so if I do the calculations here, we only care about the sign. The numerator is always positive. And this time we're subtracting a number that's bigger than 1, so the bottom is going to be negative, right? So 1 minus a bigger number than 1 will give you a negative answer there. So this means we have negative infinity from the left-hand side. Okay, so how do I write a limit statement there? I can write the limit as x approaches 1 from the right-hand side of f of x. Basically what's happening there is we're going to negative infinity. Okay, so that's it for the vertical asymptote when we approach 1. So once again, when we're going back to the vertical asymptotes, there's vertical asymptotes at 1 and negative 1. We just finished the analysis on positive 1, and now we're going to move on and do the analysis on negative 1 here. So let's go ahead and find a left-hand side and a right-hand side. And let's go ahead and pick numbers on the left-hand side and the right-hand side of negative 1. Maybe on the left-hand side I can pick negative 1.01, and on the right-hand side I can pick negative 0.9. And our original function was y equals to x squared divided by 1 minus x squared. Okay, so let's take a look at the left-hand side first. Okay, so if I take a look at the left-hand side first, we're going to plug in negative 1.01 squared. So it's that part right there. And then we divide that by 1 minus bracket negative 1.01 all squared. And then if we go ahead and analyze the results here, the numerator is always going to be positive. And on the denominator here, well, if I take this number here and if I square it, that number is going to definitely be bigger than 1. So 1 minus a number that's bigger than 1 will give you a negative result on the denominator. So this means you have negative infinity when we approach negative 1 from the left-hand side. All right, so how do I write that down? I write a limit statement here. And as x approaches negative 1 from the left, right, of the function, the original function here, we have negative infinity as an answer there. Okay, we're done with the left-hand side. Now let's move on to the right-hand side. Now on the right-hand side, I have negative 0.9. So anytime I see an x, I'm going to replace all those x's with negative 0.9. All right, so if we do that, I get negative 0.9 all squared divided by 1 minus bracket negative 0.9 all squared. And so we continue here. I guess I'll say that the numerator is always positive. And this number right here, right, if you're less than 1, like 0.9 is less than 1, and if we square it, that's still going to be less than 1. So if I have 1 subtract a number that's less than 1, that should be a positive result there. So this is going to be positive infinity. Okay, so how do I write the limit statement for that? The limit as x approaches -1 from the right-hand side of f of x, this is going to be positive infinity. Alright, so those are our answers, and what we'll do now is I will have a little graph here to kind of finish off this question here. So this is what the graph will look like if you were graphing it, and we do have 4 limit statements that we found because we had 2 vertical asymptotes. So we had a vertical asymptote at roughly at -1, so we want to know what's happening to the left and the right of -1, and we also have a vertical asymptote at +1, and we want to find out what's happening to the left and the right hand side of at x equals to 1, right? So if I approach 1, so let's take a look at this vertical asymptote here, right? So let's just kind of finish off this video by just restating the answers here. If I approach 1 from the right hand side is just down here. All right, so if I'm approaching 1 from the right hand side, I'm going down to -infinity, right? And if I approach 1 from the left hand side, that's this direction over here, right? 1 from the left-hand side, that's going to be positive infinity. Okay, so hopefully our answers match up with the graph here. And if I approach -1, let's take a look at -1 now. If I approach -1 from the left-hand side, if I'm approaching it from the left-hand side, it looks like I'm going to -infinity, right? So this limit is also going to be -infinity. And if I approach 1 from the right-hand side, basically that's over here where the graph is kind of shooting up over here from the right-hand side. And that's going to positive infinity. Okay, so hopefully that graph right there kind of just restates the answers and what the answers mean. We're talking about the behavior of the graph when we approach the vertical asymptote from the left and the right hand side. Okay, let's move on to the next question here. This time I have a radical on the denominator here. So we still take that radical on the denominator there, the square root of 2 minus x, and we want to find the vertical asymptote by making it equal to 0. Then we can square both sides, and we do that, I get 2 minus x equals to 0, and then x would equal to 2. So I have a vertical asymptote when x equals to 2. Alright, so let's go ahead and put 2 on the number line here, and then we have a left-hand side and we have a right-hand side. So automatically maybe we should go and find the numbers on the left and the right-hand side. So maybe this is a 1.9, and this is going to be a 2.01. And then what we're going to do is if I take a look at the left-hand side like the left-hand side like 1.9, we're going to plug that back into our original function there, right? So y would equal to, well, I have 1.9 on the numerator divided by the square root of 2 minus 1.9 and then plus 3. The plus 3 doesn't really matter for vertical asymptotes. Now if we go ahead and evaluate this, the numerator is going to be positive, and the denominator is also going to be positive, so we get positive infinity here. Alright, so our limit statement is the limit as x approaches 2 from the left-hand side of f of x, we are actually going to positive infinity. Okay, let's take a look at what happens when we approach this function from the right-hand side. And something interesting will happen here. So I have 2.01. And we're going to plug that into our function. So 2.01 on the numerator and 2.01 inside the radical on the denominator. If I go ahead and evaluate this, the numerator is positive, but on the denominator there, I have 2 minus that, which gives me a negative number, but then we're also taking the square root of a negative number, right? And pretty much that's impossible. So what that means is nothing is actually happening on the right-hand side of this graph. So when we have a vertical asymptote of 2, that means there's nothing on the right-hand side, like the domain does not exist on that part of the graph there. So we only have this limit statement here to conclude. Okay, so let's go ahead and take a look at the graph here so that we understand what's going on. So here's my graph, and as you can see, here's my vertical asymptote at 2. There's my vertical asymptote, and as I was mentioning before, there's nothing on the right-hand side of that vertical asymptote, right? And that's because the domain does not exist over there. And if I approach 2 from the left-hand side, as you can see, I'm going straight up, and I get to positive infinity there, right? So that graph definitely confirms the answer that we came up with in our previous steps. Great. Let's move on to question number 7 here. So question number 7, we do need to simplify this as much as possible because it looks like we might have a hole here. So let's go ahead and factor the numerator, pull out an x. So it'll be x times x plus 2. And then on the denominator here, I guess we can factor the denominator here. We need two numbers that multiply to -6 and add to -1. So I have an x here, an x there. I guess I can have -3 and plus 2. And it turns out that these two can cancel off, and I'm left with just x over x minus 3. And then if I take a look at my denominator there, so just hold on. So this means we have a vertical asymptote at x equals to 3. And over here, we've just established that we have a hole when x equals to -2. All right, so we're not so interested about the hole. We're more interested about the vertical asymptote. So I will put the number 3 on my number line here, and then we'll look at the left-hand side, and then we will also look at the right-hand side. And automatically, a number on the left-hand side could be 2.9, and a number on the right-hand side could be 3.01. Now, when I go back to my function now, let's take the most simplified form, which is going to be this thing in the green box. So that's going to be x over x minus 3. Okay, so let's go ahead and figure out what's happening when we, let's start on the left-hand side as always. So whenever I see an x in my function here, I'll replace that with 2.9. Okay, so I have 2.9 on the numerator. On the denominator, I have 2.9 and then minus 3. Okay, so the numerator is positive and the denominator is going to be negative. So when I write a limit statement here, the limit as x approaches 3 from the left of f of x equals to, well, positive over negative is going to be negative infinity. So negative infinity. Okay. All right, let's erase all this now. All right, now let's take a look at the number on the right-hand side, which is 3.01. So let's go ahead and plug 3.01 for x. So I get 3.01 on the numerator, 3.01 on the denominator, and then minus 3. And then we have a positive on the top, and on the denominator, we also have a positive expression giving us positive infinity. All right, so if I write a limit statement now, I have the limit as x approaches 3 from the right-hand side of this function of f of x. That's going to equal to positive infinity there. Okay, so that should definitely conclude our homework video guide, but I do have one last graph here to kind of illustrate the results here. So here's the graph if I graph the entire thing on Desmos. It looks like there is a vertical asymptote right here at 3. And if I approach this graph, if I approach the vertical asymptote 3 from the right-hand side right there, we're going to positive infinity there. And if I approach 3 from the left-hand side, it's going straight down, so that's going to be negative infinity, right? So that definitely matches the answers that we have, and hopefully that will give you a better understanding of what we're trying to do in these homework problems.